Hey everyone, how's it going? So this is going to be the last lesson for the powers and exponents unit, and it's just going to follow up on some more exponent laws that are important to know if you're going to continue in math. So I'll just wait for the slideshow to load. Okay, so before we start talking about the new stuff, here are just a few mental math questions for you to try. So pause the video, give them a shot, and then we will go over the solutions together. So the first one is 3 to the power of 2 times 3 to the power of 3. So remember, when we're multiplying powers that have the same base, or the same big number, we just add the exponents together, 2 plus 3, and we get 3 to the power of 5. If there's a divide and the powers have the same base, we just subtract the exponents, so we get 6 minus 4, and it equals 4 to the power of 2. We can do multiply and divide at the same time. So if we see a multiply when the base numbers are the same, we just add, and when we see a divide, we subtract, and it doesn't matter which order you do it in, you should get the same answer. So 2 plus 4 is 6, minus 3 equals 3, so it's 5 to the power of 3. And then this last one, 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2, we just do 2 plus 2 plus 2, which equals 3 to the power of 6. And questions like that last one, that is going to be part of the first exponent law that we're going to talk about today. So we see here 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2. We're multiplying three things that are the same. We're multiplying 3 to the power of 2 3 times. And what can we do when we're multiplying things that are the same? Well, if you think back to the very first lesson in this unit, we can use powers. So our base, our big number, would be this whole thing, 3 to the power of 2, and we're multiplying it 3 times, so the exponent would be 3. So it equals 3 to the power of 2 to the power of 3. Sort of like power inception. It's a power within a power. And when we did the question, 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2, we found that it equaled 3 to the power of 6. So if that equals 3 to the power of 2 to the power of 3, and it equals 3 to the power of 6, do you notice anything happening with the exponents? So if you want, you can pause and think about it. I'm also going to show another example here. So here's 3 to the power of 2 to the power of 4. That means that we're multiplying 3 to the power of 2 4 times. So 1, 2, 3, 4. And when we are multiplying numbers that have the same base, we just add the exponents together. So 2 plus 2 plus 2 plus 2. And we get 3 to the power of 8. So 3 to the power of 2 to the power of 4 equals 3 to the power of 8. But hold on, 2 times 4 equals 8. Is it a coincidence? Usually when I ask that, that means it's not a coincidence. So in general, when we raise a power to another power, we just multiply the exponents. So if I have a number to the power of n to the power of m, I just multiply n and m together to get our new exponent. So here are a couple more examples. Negative 5 to the power of 3 to the power of 2. We just do 3 times 2, and it equals negative 5 to the power of 6. And then there's another example here. We have an exponent of 3 and then an exponent of 4. So we just multiply 3 times 4 together, and we get negative 2 to the power of 12. So again, here I'll ask you to pause the video, maybe try these check questions to get on your own before we go through the answers together. So just pause it here, and then we'll go over the answers. So 9 to the power of 3 to the power of 4, we just multiply 3 times 4, and we get 9 to the power of 12. Negative 2 to the power of 5 to the power of 3 is just negative 2 to the power of 5 times 3, which is negative 2 to the power of 15. And this last one, negative 5 to the power of 4 to the power of 2 equals negative 5 to the power of 4 times 2, which equals negative 5 to the power of 8. Okay, so this is the next exponent law we're going to talk about. This one isn't really as important, but it's still an interesting thing to know. So this is where we're multiplying two numbers and then to the power of something else. So 3 times 4 to the power of 2 is the example we're going to be looking at. So this power of 2 means we're multiplying whatever is here 2 times. So 3 times 4 times 3 times 4. Now because it's multiplication and we're just multiplying everything, we can get rid of these brackets and we just say that's 3 times 4 times 3 times 4. So it's just like saying 3 times 2 is the same thing as 2 times 3. You can do it in whatever order you want, which is what happens here. I just rearrange this 3 and this 4, and I get 3 times 3 times 4 times 4. 3 times 3, we're multiplying the number 3 2 times. So that's 3 to the power of 2 times 4 to the power of 2, because we're multiplying the number 4 2 times. So 3 times 4 to the power of 2 equals 3 to the power of 2 times 4 to the power of 2. Notice how the 2 just goes here with the 3, and it goes here with the 4, down here in the answer. That's all that this law is saying. So here we can see it in math terms. A times b to the power of n is just a to the power of n times b to the power of n. And we can also solve these. So 2 times 5 to the power of 2 is 2 to the power of 2 times 5 to the power of 2, which is 2 times 2 times 5 times 5, which is 4 times 25, which equals 100. Or, if we're using the laws of BEDMAS, we can simplify the brackets first, and we do 2 times 5, which equals 10. So then we just do 10 to the power of 2, which equals 100. And if you're doing this on your calculators, I'm just going to show you here quickly how you can punch it in. So, there's something on there. So I'm going to do brackets 2 times 5, and then I'm going to close the brackets, and then to the power of 2. So it's kind of hard to read it there. But when I hit equals, I get equals 100. So we can take a look at another example. Negative 3 times 4 to the power of 2. We can either do the powers on both, which is actually a bit of a longer way to do it, or we can just say negative 3 times 4 equals negative 12, and negative 12 to the power of 2 equals 144. Okay, so try the next couple of questions on your own. I believe that the first ones are just simplifying, and then the next ones we're going to actually solve it and find an answer. So 5 times 7 to the power of 4 is just 5 to the power of 4 times 7 to the power of 4. So the 4 just goes with each one. Same thing, 8 times 2 to the power of 2 is just 8 to the power of 2 times 2 to the power of 2. And then try solving these ones as well. So again, pause the video, take a few minutes to try to solve them. So negative 1 times 6 to the power of 2, well, negative 1 times 6 is negative 6. And when we do that to the power of 2, we get 36. And negative 1 times negative 4 to the power of 3. Negative 1 times negative 4 equals 4. So it's just 4 to the power of 3, which equals 64. And again, if you just punch this directly into your calculator, you should get the exact answer. Okay, so this is the last exponent law. We can do the same thing when we divide numbers that have the same power. So I'll show you what I mean by that. If we have 3 over 4 to the power of 2, it equals 3 to the power of 2 divided by 4 to the power of 2. So just like how when we're multiplying, the power went with each number, when we divide, the power can also go with each number. And here it is in math terms. A divided by b to the power of n equals a to the power of n divided by b to the power of n. We can also solve those ones. Again, you can just punch this directly into your calculator. 30 divided by negative 5 to the power of 2. Well, 30 divided by negative 5 equals negative 6. And then when we do that to the power of 2, it equals 36. We get, here's another example, sorry. 20 divided by 4 to the power of 2. 20 divided by 4 equals 5. And then 5 to the power of 2 equals 25. Or you can also work it out in the same way in the example above here. So try to do these questions yourself first. Again, pause the video and then we'll go over the answers. So 3 divided by 4 to the power of 5 is just 3 to the power of 5 divided by 4 to the power of 5. And 1 divided by negative 10 to the power of 3 is 1 to the power of 3 divided by negative 10 to the power of 3. And again, pause the video here, try to solve these before watching the answers. So negative 16 divided by negative 4 to the power of 2 is, well, negative 16 divided by negative 4 equals positive 4. And positive 4 to the power of 2 equals 16. And then for the other example, 36 divided by 6 to the power of 3. Well, 36 divided by 6 equals 6. And 6 to the power of 3 equals 216. So there are some practice questions for you to try on page 86 and 87 if you are working through the notes package. If you'd rather do the online assignment, there will be a link posted in the Google Classroom. You can also try, if you're doing the notes package, you can try the puzzle that's on the last page. That one is like more of a review of everything that we've talked about so far about powers and exponents. If you guys have any questions, you can always let me know. But that's it for this video and for the unit. So there will be a review assignment posted and then a quiz posted as well sometime in the next week. But until then, have a good day, guys. Stay safe. See you.